A gemstone or gem is a piece of mineral crystal, which, in cut and polished form, is used to make jewelry or other adornments. However, certain rocks or organic materials that are not minerals, are also used for jewelry, and are therefore often considered to be gemstones as well. Most gemstones are hard, but some soft minerals are used in jewelry because of their luster or other physical properties that have aesthetic value. Rarity is another characteristic that lends value to a gemstone. Apart from jewelry, from earliest antiquity engraved gems and hard stone carvings, such as cups, were major luxury art forms. A gem maker is called a lapidary or gem cutter, a diamond worker is a diamantaire. The carvings of Carl Faber are significant works in this tradition. Characteristics and classification. The traditional classification in the West, which goes back to the ancient Greeks, begins with a distinction between precious and semi-precious. Similar distinctions are made in other cultures. In modern usage, the precious stones are diamond, ruby, sapphire and emerald, with all other gemstones being semi-precious. This distinction reflects the rarity of the respective stones in ancient times, as well as their quality. All are translucent, with fine color in the purest forms, except for the colorless diamond, and very hard, with hardnesses of 8 to 10 on the Mohs scale. Other stones are classified by their color, translucency, and hardness. The traditional distinction does not necessarily reflect modern values. For example, while garnets are relatively inexpensive, a green garnet called savret can be far more valuable than a mid-quality emerald. Another unscientific term for semi-precious gemstones used in art history and archaeology is hardstone. Use of the terms precious and semi-precious in a commercial context is, arguably, misleading in that it deceptively implies certain stones are intrinsically more valuable than others, which is not the case. In modern times, gemstones are identified by gemologists, who describe gems and their characteristics using technical terminology specific to the field of gemology. The first characteristic a gemologist uses to identify a gemstone is its chemical composition. For example, diamonds are made of carbon and rubies of aluminium oxide. Next, many gems are crystals which are classified by their crystal system, such as cubic or trigonal or monoclinic. Another term used is habit, the form the gem is usually found in. For example, diamonds, which have a cubic crystal system, are often found as octahedrons. Gemstones are classified into different groups, species, and varieties. For example, ruby is the red variety of the species corundum, while any other color of corundum is considered sapphire. Other examples are the emerald, aquamarine, red beryl, goshenite, heliodor, and morganite, which are all varieties of the mineral species beryl. Gems are characterized in terms of refractive index, dispersion, specific gravity, hardness, cleavage, fracture, and luster. They may exhibit pleochroism or double refraction. They may have luminescence and a distinctive absorption spectrum. Material or flaws within a stone may be present as inclusions. Gemstones may also be classified in terms of their water. This is a recognized grading of the gem's luster and or transparency and or brilliance. Very transparent gems are considered first water, while second or third water gems are those of a lesser transparency value. There is no universally accepted grading system for gemstones. Diamonds are graded using a system developed by the Gemological Institute of America in the early 1950s. Historically, all gemstones were graded using the NACO die. The GIA system included a major innovation: the introduction of 10x magnification as the standard for grading clarity. Other gemstones are still graded using the NACO die. A mnemonic device, the 4Cs, has been introduced to help the consumer understand the factors used to grade a diamond. With modification, these categories can be useful in understanding the grading of all gemstones. The 4 criteria carry different weight depending upon whether they are applied to colored gemstones or to colorless diamonds. In diamonds, cut is the primary determinant of value, followed by clarity and color. Diamonds are meant to sparkle, to break down light into its constituent rainbow colors, chop it up into bright little pieces, and deliver it to the eye. In its rough crystalline form, a diamond will do none of these things. It requires proper fashioning, and this is called cut. In gemstones that have color, including colored diamonds, it is the purity and beauty of that color that is the primary determinant of quality. Physical characteristics that make a colored stone valuable are color, clarity to a lesser extent, cut, unusual optical phenomena within the stone such as color zoning and asteria. The Greeks, for example, greatly valued asteria gemstones, which were regarded as powerful love charms, and Helen of Troy was known to have worn star corundum. Aside from the diamond, the ruby, sapphire, emerald, pearl and opal have also been considered to be precious. Even in the last century, certain stones such as aquamarine, peridot and cat's eye have been popular and hence been regarded as precious. Nowadays such a distinction is no longer made by the gemstone trade. Many gemstones are used in even the most expensive jewelry, depending on the brand name of the designer, fashion trends, market supply, treatments, etc. Nevertheless, diamonds, rubies, sapphires, and emeralds still have a reputation that exceeds those of other gemstones. Rare or unusual gemstones, generally meant to include those gemstones which occur so infrequently in gem quality that they are scarcely known except to connoisseurs, include andalusite, axonite, cassiterite, clinohumite and red beryl. Gem prices can fluctuate heavily or can be quite stable. In general, per carat prices of larger stones are higher than those of smaller stones, but popularity of certain sizes of stone can affect prices. Typically, prices can range from $1 per carat for a normal amethyst to $20,000 minus $50,000 for a collector's 3-carat pigeon blood almost perfect ruby. Grading. There are a number of laboratories which grade and provide reports on gemstones. Gemological Institute of America, the main provider of education services in diamond grading reports, and also color stone reports. International Gemological Institute, independent laboratory for grading and evaluation of diamonds, jewelry and colored stones. Hodge Raad voor Diamond, the Diamond High Council, Belgium is one of Europe's oldest laboratories. Its main stakeholder is the Antwerp World Diamond Center. American Gemological Society is not as widely recognized nor as old as the GIA. American Gem Trade Laboratory, which is a part of the American Gem Trade Association, a trade organization of jewelers and dealers of colored stones. American Gemological Laboratories, owned by Christopher P. Smith. European Gemological Laboratory, founded in 1974 by Guy Margel in Belgium. Gemological Association of All Japan, Zenhokyo, Japan, active in gemological research. The Gem and Jewelry Institute of Thailand or GIT, the Thailand's National Institute for Gemological Research and Gem Testing, Bangkok. Gemology Institute of Southern Africa, Africa's premium gem laboratory. Asian Institute of Gemological Sciences, the oldest gemological institute in Southeast Asia, involved in gemological education and gem testing. Swiss Gemological Institute, founded by Henry Hanna, focusing on colored gemstones in the identification of natural pearls. Gubelin Gem Lab, the traditional Swiss lab founded by Eduard Gubelin. Each laboratory has its own methodology to evaluate gemstones. A stone can be called pink by one lab while another lab calls it padparadsha. One lab can conclude a stone isn't treated, while another lab might conclude that it is heat-treated. To minimize such differences, 7 of the most respected labs, AGTA GTL, CISGEM, GAAJZENHOKYO, GIA, GIT, Gubelin and SSEF, have established the Laboratory Manual Harmonization Committee, for the standardization of wording reports. promotion of certain analytical methods and interpretation of results. Country of origin has sometimes been difficult to determine, due to the constant discovery of new source locations. Determining a country of origin is thus much more difficult than determining other aspects of a gem. Gem dealers are aware of the differences between gem laboratories and will make use of the discrepancies to obtain the best possible certificate. Cutting and polishing. A few gemstones are used as gems in the crystal or other form in which they are found. Most, however, are cut and polished for usage as jewelry. The picture to the right is of a rural, commercial cutting operation in Thailand. This small factory cuts thousands of carats of sapphire annually. The two main classifications are stones cut as smooth dome-shaped stones called cabochons, and stones which are cut with a faceting machine by polishing small flat windows called facets at regular intervals at exact angles. Stones which are opaque or semi-opaque such as opal, turquoise, baryshite, etc., are commonly cut as cabochons. These gems are designed to show the stone's color or surface properties as in opal and star sapphires. Grinding wheels and polishing agents are used to grind, shape and polish the smooth dome shape of the stones. Gems which are transparent are normally faceted, a method which shows the optical properties of the stone's interior to its best advantage by maximizing reflected light, which is perceived by the viewer as sparkle. There are many commonly used shapes for faceted stones. The facets must be cut at the proper angles, which varies depending on the optical properties of the gem. If the angles are too steep or too shallow, the light will pass through and not be reflected back toward the viewer. The faceting machine is used to hold the stone onto a flat lap for cutting and polishing the flat facets. Rarely, some cutters use special curved laps to cut and polish curved facets. Color. The color of any material is due to the nature of light itself. Daylight, often called white light, is actually all of the colors of the spectrum combined. When light strikes a material, most of the light is absorbed while a smaller amount of a particular frequency or wavelength is reflected. The part that is reflected reaches the eye as the perceived color. A ruby appears red because it absorbs all the other colors of white light, while reflecting the red. The same material can exhibit different colors. For example, ruby and sapphire have the same chemical composition but exhibit different colors. Even the same gemstone can occur in many different colors. Sapphires show different shades of blue and pink, and fancy sapphires exhibit a whole range of other colors from yellow to orange-pink, the latter called Padparadscha sapphire. This difference in color is based on the atomic structure of the stone. Although the different stones formally have the same chemical composition, they are not exactly the same. Every now and then an atom is replaced by a completely different atom. These so-called impurities are sufficient to absorb certain colors and leave the other colors unaffected. For example, beryl, which is colorless in its pure mineral form, becomes emerald with chromium impurities. If manganese is added instead of chromium, beryl becomes pink morganite. With iron, it becomes aquamarine. Some gemstone treatments make use of the fact that these impurities can be manipulated, thus changing the color of the gem. Treatment. Gemstones are often treated to enhance the color or clarity of the stone. Depending on the type and extent of treatment, they can affect the value of the stone. Some treatments are used widely because the resulting gem is stable, while others are not accepted most commonly because the gem color is unstable and may revert to the original tone. Heat can improve gemstone color or clarity. The heating process has been well known to gem miners and cutters for centuries, and in many stone types heating is a common practice. Most citrine is made by heating amethyst, and partial heating with a strong gradient results in ametrine, a stone partly amethyst and partly citrine. Much aquamarine is heated to remove yellow tones and change the green color into the more desirable blue or enhance its existing blue color to a purer blue. Nearly all tanzanite is heated at low temperatures to remove brown undertones and give a more desirable blue-purple color. A considerable portion of all sapphire and ruby is treated with a variety of heat treatments to improve both color and clarity. When jewelry containing diamonds is heated, the diamond should be protected with boracic acid, otherwise the diamond could be burned on the surface, or even burned completely up. When jewelry containing sapphires or rubies is heated, it should not be coated with boracic acid or any other substance, as this can etch the surface. They do not have to be protected like a diamond. Radiation. Virtually all blue topaz, both the lighter and the darker blue shades such as London blue, has been irradiated to change the color from white to blue. Most greened quartz is also irradiated to achieve the yellow-green color. Waxing. Oiling. Emeralds containing natural fishes are sometimes filled with wax or oil to disguise them. This wax or oil is also colored to make the emerald appear of better color as well as clarity. Turquoise is also commonly treated in a similar manner. Fracture filling. Fracture filling has been in use with different gemstones such as diamonds, emeralds and sapphires. In 2006, glass-filled rubies received publicity. Rubies over 10 carats with large fractures were filled with lead glass, thus dramatically improving the appearance. Such treatments are fairly easy to detect. Synthetic and artificial gemstones. It is important to distinguish between synthetic gemstones and imitation or simulated gems. Synthetic gems are physically, optically and chemically identical to the natural stone, but are created in controlled conditions in a laboratory. Imitation or simulated stones are just that, imitations, and can be glass, plastic, resins or other compounds. Examples of simulated or imitation stones include cubic zirconia, composed of zirconium oxide, and simulated moissanite, which are both diamond simulants. The imitations copy the look and color of the real stone but possess neither their chemical nor physical characteristics. Moissanite actually has a higher refractive index than diamond, and when presented beside an equivalently sized and cut diamond will have more fire than the diamond. However, synthetic, cultured, or lab-created gemstones are not imitations. For example, diamonds, rubies, sapphires and emeralds have been manufactured in labs to possess identical chemical and physical characteristics to the naturally occurring variety. Synthetic corundum, including ruby and sapphire, are very common and they cost only a fraction of the natural stones. Smaller synthetic diamonds have been manufactured in large quantities as industrial abrasives. Although larger gem-quality synthetic diamonds are becoming available in multiple carats. Whether a gemstone is a natural stone or lab-created, the physical characteristics are the same. Lab-created stones tend to have a more vivid color to them, as impurities are not present in a lab and do not modify the clarity or color of the stone, unless added intentionally for a specific purpose. The rarest gemstones in the world. Painite. Painite was discovered in 1956 in Ongaring in Myanmar. The mineral was named in honor of the British gemologist Arthur Charles Davy Payne. In 2005, painite was described by the Guinness Book of World Records as the rarest gem mineral on Earth. Hibernite. Hibernite was discovered in 1956 in Madagascar. It was named after the discoverer, the French geologist Paul Hibern. Gem-quality hibernite has only been found in Myanmar. Red beryl or bixbite. Red beryl or bixbite was discovered in an area near Beaver, Utah in 1904 and named after the American mineralogist Maynard Bixby. Jeremehovite. Jeremehovite was discovered in 1883 in Russia and named after its discoverer, Pavel Vladimirovich Jeremju. Chambersite. Chambersite was discovered in 1957 in Chambers County, Texas, USA, and named after the deposit's location. Tar aphyta. Tar aphyta was discovered in 1945. It was named after the discoverer, the Irish gemologist Count Edward Charles Richard Taaffe. Musgravite was discovered in 1967 in the Musgrave Mountains in South Australia and named for the location. Granadierite was discovered by Antoine-François Alfred Lacroix in 1902 in Tulare Province, Madagascar. It was named in honor of the French naturalist and explorer Alfred Granadier. Poudretite was discovered in 1965 at the Poudret Quarry in Canada and named after the quarry's owners and operators, the Poudret family. Serendipity was discovered in Sri Lanka by Dunil Palithagunnasekera in 1902 and named after Serendib, the Old Arabic name for Sri Lanka. Zetzerite was discovered by Bart Cannon in 1968 on Kangaroo Ridge near Washington Pass in Okanagan County, Washington, USA. The mineral was named in honor of mathematician and geologist Jack Zetzer, who presented the material for study in 1976.